Hey guys, so in today's video I'm going to be showing you how to make a drivable car with suspension. So to get started, I'm first going to create a model in my workspace. So let's create a model and I'm going to name this model car, and then I'm going to get the body of the car. So I'm going to open the toolbox. You can use your own mesh, but I'm going to find one from the toolbox. So I'm going to meshes and I'm going to search for car no wheel. And I'm going to pick this red car here, and I'm going to place this car into the car model, and I'm going to rename it to mesh part. I'm now going to make a few changes to this mesh part. The first thing I'm going to do is adjust the size to make it a bit more larger so I can fit inside. And then I'm going to adjust the position. And slightly move it over. Okay. The next thing I'm going to change is the mass of the body. And I've found that a mass of around 80 seems to work good, but you can mess around with different masses to find what works best for you. So here we can see the mass is currently 192. So if I enable custom physical properties, and if I open here, we can see the density is set to 0.7. And if I adjust the density, we can see that the mass changes. So I'm going to reduce this to 0.3. And now we can see that the mass is 82, which is roughly how I like it. The next thing I'm going to do is set the model primary part to be the body. So here we can see the primary part is set to nothing. So if I click here and then click on the mesh part, which is the body, now we can see that the primary part has been set to the mesh part. Now let's create a wheel. So I'm going to add a part to the model, and I'm going to rename this part to wheel FL, and FL stands for front left because this is going to be the front left wheel. And I'm going to come down to shape and change the shape to a cylinder, and I'm also going to set the size, and I'm also going to change the color to black. I'm now going to open the toolbox once again, and inside of the images category search for wheel, and I'm going to select this wheel image here, and I'm going to change the face to be the left face, And I'm also going to rename this image to decal. Now let's attach the wheel to the body. So to do this, I'm going to create an attachment on the wheel. So let's create an attachment, and I'm also going to create an attachment on the body. And I'm going to rename this attachment to be FL, so we know it's the front left attachment. And I'm slightly going to position this attachment so it comes to the wheel area where I want the wheel to be. And here we can see the attachment over here on the wheel. And now inside of the wheel I'm going to make a cylindrical constraint. So let's create a cylindrical constraint, and for attachment 0 I'm going to select the attachment that's inside of the mesh part, which is the body, and for attachment number 1 I'm going to select the attachment that's inside of the wheel. Now in order to test this wheel, what I'm going to do is anchor the body. So I'm going to select this mesh part, and I'm going to come down to anchored and set it to true. Now let's test the wheel by playing the game. And we should see that the wheel has moved to the attachment and the wheel should spin. And we should also see that the wheel moves weirdly along this axis, and we should also notice that if we push the wheel into the car, it collides with the car. So let's first fix the problem of the wheel colliding with the car. So to prevent the wheel and the body from colliding with one another, I'm going to come over to this model group tab, and over here there is a collision group button. So I'm going to press this button and this window should appear, and I'm going to add a new group called car, and I'm going to add another group called wheel, and I'm going to select the body, and I'm going to press this little plus sign to add the body to the car group. And now I'm going to select the wheel and press the little plus sign next to the wheel group, and I'm going to stop them from colliding by unticking the wheel and the car where the arrow intersect. So this arrow here needs to be turned off so that the wheel and the car do not collide with one another. So if we play the game once again, we should now see that the wheel is inside of the car, and if we push it, it can go through the car because it now no longer collides with the car. Now let's fix this movement direction from going from left to right to up and down. So I'm going to select the attachment that's inside of the body of the car, and I'm going to rotate the orientation by 90 degrees on the Z axis. And if we play the game once again, we should now see that the wheel goes down, and the wheel is now rotated incorrectly. So, and it's kind of difficult to push it up and down, but if we could, we would see that the wheel would move up and down along this axis. So to fix the orientation of the wheel, I'm going to select the cylindrical constraint, and I'm going to scroll down to inclination angle and set this to 90. And if we play the game once again, we should now see that the wheel is rotated correctly, but the decal is on the inside, not the outside. And to fix the decal being on the incorrect side, I'm going to select the attachment and I'm going to rotate the orientation by 180 degrees. If I now move the body of the car up and play the game, we can see that the wheel goes for an infinite amount of distance downwards and also would go for an infinite amount of distance upwards. So we must add a limit to the cylindrical constraint. So to add the limit, I'm going to select the cylindrical constraint and I'm going to scroll down and I'm going to enable limits enabled. And for the upper limit, I'm going to set -1, and for the lower limit I'm going to set -2. Let me explain why I set the upper limit and lower limit to -1 and -2. Here we can see the attachment for the body, which is this attachment FL, and here we can see the attachment for the wheel, and these green dots represent the attachments. So by setting the limits from -1 to -2, that means the wheel's attachment can move from -1 down to -2. So if you wanted to give the wheel more room to move, for instance, let's say you're making a monster truck that has very large suspension, you can increase the or decrease the -2 to, for instance, -4, and that would allow the attachment to move all the way down to -4 instead of -2 like we have set now. And if we changed the upper limit from -1 to 0, that would allow the attachment of the wheel to go up to 0. But we don't want to do this. In the future, when we add a spring between these two attachments, so let's imagine we have a spring that's attached to these two attachments, and if this attachment comes all the way up to this attachment, the spring will not work correctly. So in order to prevent the spring from not working correctly, I have intentionally set the upper limit to -1 so that this attachment can only come up to here, allowing for the spring to have a little bit of room to work correctly in this area. So now that we've set our limits, let's play the game. And we should now see that the wheel no longer comes all the way down to the floor, and if I hit the wheel from underneath, we can see that it doesn't go all the way up and stops at -1 from the attachment. Now let's create a spring. So inside of the wheel, I'm going to create a spring constraint. And just like we did for the cylindrical constraint, I'm going to set attachment 0 to the attachment FL, which is the one that's inside of the mesh part. And for attachment number 1, I'm going to set the attachment that's inside of the wheel. I'm going to scroll to the bottom and set damping to 200 and free length to 2.8 and stiffness to 3500. But feel free to mess around with these settings to get the spring tension that you feel is fit for your car. Now I'm going to slightly adjust the physics of the wheel. So let's select the wheel and scroll down to custom physics properties, and let's enable this, and I'm going to set the density to 2, and I'm going to reduce the elasticity from 0.5 to 0.2 so that they don't bounce too much on the floor, and I'm also going to increase the friction, but this is personal taste. It will affect how if they can drift or slide around on the floor. So I'm going to set this to 1.5. Now, while the position of this wheel has no effect, in order to keep my model nice and tidy, I'm going to select the attachment that's on the body and copy the world position and paste that position into the wheel. So the wheel goes into position. I'm going to move it down 2 studs so that the wheel is roughly in the correct position. Now that the front left wheel is complete, let's make the front right wheel. So to do this, I'm going to select the attachment FL and hold the control key and select the wheel FL and then press Ctrl D to duplicate. I'm then going to move the duplicated wheel to the other side and I'm going to rename the FL to FR for front right, and the same for the wheel model, FR. Now, because we duplicated the attachment and the wheel together, Roblox should have automatically updated our spring and cylindrical constraint to have this as the attachment. But if you duplicated the attachment and the wheel separately, then the constraints would not have updated to this new attachment. So in order to make sure that your constraints are attached, set to this attachment, you want to open your new wheel, the FR, and select your constraints, and you want to make sure that the attachment 0 is set to the correct attachment. So wheel FR is attached to attachment FR, and the same for the spring, so attachment FR for the spring as well. So now let's align our wheel so it's perfectly in the correct position, the same way this one is. So to do this, I'm going to select my front left attachment, and I can see that the position is at 2.6. So I'm going to copy this position, and I'm going to select the front right and make sure the position is the same. So it says 2.6. So now we can see that the attachment moved to the correct position. Then I'm going to get the world position on the x-axis, and I'm going to select my front right wheel, and I'm going to set the wheel's position to be the same as the attachments. And now you can see that my wheel is perfectly in the correct position like the other wheel. And to fix the decal being on the inside, I'm going to select the decal and change the face to be from the left to the right. And now we can see that the wheeled decal is on the correct side as well. So in order to create the back 2 wheels, I'm going to select the front left attachment and then hold the control key and select the front right, and then the front left wheel and the front right wheel. Then I'm going to press Ctrl D to duplicate, and I'm going to move these wheels back. Then I'm going to rename the attachments and wheels. So from FL it's going to be BL, and from FR it's going to be back right, and this is going to be back left, and this one's going to be back right. I am now going to align the back 2 attachments. So I'm going to select both by holding the control key, and I'm going to go to position and press this little arrow to the left, and I'm going to change the z-axis from 10 to 4.9, so we can see that both have been moved into the wheel hub. And then I'm going to go to world position and get the Z position and copy this and select both the back wheels and press the little arrow next to position and change the Z position from 10 to 4.9. Now if you followed my video correctly, all the wheels should be rotating in the correct direction. So to test that, I'm going to run the game. and I'm going to open workspace, select my car model, open all the wheels, and I'm going to select the cylindrical constraints for all 4 wheels, and I'm going to scroll down to angular actuator type. I'm going to set this to motor, and 3 new properties should appear, and I'm going to set angular velocity to 1 and max torque to 5,000, and we should see that all the wheels rotate forwards with a positive number. So we can see it's rotating forward, and we check this side, they're all rotating forward. And if we use a negative number, they should all be rotating backwards, and you can see they're rotating all backwards. So all our wheels are rotating the correct direction. Now if we select the mesh of the car and scroll down to anchored and set anchored to false and play the game, you may notice that the back wheels are more compressed than the front wheels, and this is because the back of the car is heavier than the front of the car. So to fix this problem, what I'm going to do is stop the game, and I'm going to open the back 2 wheels and select the 2 springs, and I'm going to increase the free length from 2.8 to 3.2. And if we play the game once again, and we should now see the result of increasing the free length because the body has slightly been pushed up above the wheel. Now let's add a seat to our car. So I'm going to add a vehicle seat, and I'm going to weld the seat to the body. So I'm going to select a weld constraint, and I'm going to select the vehicle seat as part 0 and the body as part 1. If I position this seat inside of the body, we will not be able to sit on it because we won't be able to touch the seat. So for now, I'm just going to put the seat over here so that we can sit on it while we work on the scripts. The next thing I'm going to want to do is when a player sits on the vehicle seat, I want to give them network ownership of the car so they can control the car in a local script, and this is going to make the car feel very responsive and have 0 lag. The downside of giving network ownership of the car to the client is that now hackers will be able to move this car wherever they want and teleport it around the world however they want. I have a video on my channel called Stop Hackers/Exploiters, and in this video I show you how to make a script to prevent the character from moving too quickly, and you can use this same technique to prevent the car from moving too quickly when a hacker takes control of the car. So to give network ownership, inside of server script service, I'm going to create a script and delete this hello world print here. The humanoid has a event called seated, and this event fires when a humanoid either sits in a seat or vehicle seat, and also when they get off the seat. So the first thing I need to do is detect when a player enters the game. So I'm going to say game.players.player added connect function, and this function returns a player. Then I'm going to detect when this player character has loaded. So I'm going to do player.character added connect function, and this function is going to return the character model, and then I'm going to use this character model to get the humanoid, and then from this humanoid I'm going to get the seated event. So I'm going to say seated connect function. This seated event returns two variables, one boolean, so either true or false if we're seating or getting up of a chair would return false, and the part we are sitting on, or it will return nil when we're getting up from a chair. So I'm going to copy and paste these names and paste them into our function, and I'm going to call this seat part, and this one's going to be called active. And just for now I'm going to print active and seat part, and if I play the game, and if I sit on the seat, we can see it says true and it gives us the vehicle seat, and if I get up it says false and gives us the value of nil. Okay, now let's give ownership when we sit on a part. So the first thing I need to check is say if seat part equals nil, then return. So if we're getting off a seat, we're just going to exit out of this function and do nothing. The next thing I want to check is the name of the seat. Now in your game you may have many types of seats, and you only want this to work for the car seats, so you want to use a unique name for your car seats so that this script only runs for that name. I'm just going to keep it at the default vehicle seat, so I'm going to say if seat part dot name is not equal to, and I'm going to use vehicle seat. So if it's not vehicle seat, then return end. So we're just going to exit the function and not continue. And finally I'm going to say seat part set network owner, and I'm going to use the player value that we got from the player added event. So I'm going to copy and paste this into here. I'm also going to change the print to say owner, and to print the player dot name. And so if we play the game once again, and if we sit on the seat, we can see that it says owner and it says my name, and if I exit the car I still have ownership of this car, and if anyone else sits on the car, ownership will be given to them, and if I sit back on the car, the ownership will be given back to me. Now let's enable motors for our wheels. Now if you wanted four-wheel drive, you would enable it for all four of your wheels, but I'm going to only enable the motors on the back two wheels. So I'm going to open up the back left and back right. I'm going to select the cylindrical constraints. I'm going to scroll down to angular actuator type, and I'm going to set this at motor. And now I'm going to change the max torque to 2000, and this is going to act like a handbrake to prevent the car from rolling around when no one's driving. And now inside of starter player and starter character scripts, I'm going to create a new local script and delete this hello world print from here. I'm now going to get the character model, so I'm going to say local character equals script.parent, and just like we did on the script in the server script service, I'm going to detect when the humanoid sits on a seat. So I'm going to copy this line here and paste it into our local script. If we play the game, and if I jump on the seat and open workspace and open the car and select the vehicle seat and scroll to the bottom of the properties, we can see that steer and steer float equals 0, 0, and throttle float also equals 0, 0. And if I press the A key, we can see that steer goes to -1. And if I press D, it goes to +1. If I press the W key, throttle goes to 1. And if I press the S key, throttle goes to -1. And if I enable this small button here to enable mobile phone mode and press play once again, and if I jump onto the car seat and do the same again, select car and select the vehicle seat and scroll down to properties, now we can see that when I move the D-pad, the seat moves from 0 to 1 and -1, where steer float moves in smaller increments, so I have finer control. So we're going to be using the steer float and throttle float in order to control the car, so that mobile phone users have finer control and gamepad users also will have finer control over the car. In order to detect when the steer or throttle value has changed, we're going to be using the changed event, and this fires immediately after a property of an object has changed. So what I'm going to do is say seat part dot changed connect function, and this function is going to return the property that has changed. And then I'm going to say, so we're going to check to see if the property is steer float or throttle float. So I'm going to say if property equals steer float, then, and I'm also going to check if the property is throttle float, so else if property equals throttle float, then for now I'm just going to simply print the property. So I'm going to say print seat part dot steer float, and I'm also going to print the throttle float. So one more thing we need to make sure is when we exit a seat, this seat part will return nil. So this will not work, so we need to make sure that we don't do this when we get off a seat. So I'm going to say if seat part equals nil, then return. So if I play the game once again, and sit on the seat, we can see if I press the W key, it says 1. If I press the S key, it says -1. If I jump off the car, now we have a problem that even though we've got off the car, the connection has not been disconnected from the event. So I'm still receiving events when the property changes. And if I go back onto the seat and press W once again, now we can see I'm getting the 1 value 2 times, and I'm getting every value twice. And if I press S to go back, forward, every event is received twice. If I jump off and jump on again, now I should get the events 3 times. So you can see I'm getting every event 3 times, and that is because we're not disconnecting the event when we get off the seat. So to fix this problem, I'm going to create a variable at the top called connection equals nil, and when we assign this changed event, when we connect it, I'm going to store the connection into this variable here. So I'm going to say connection equals, and one more thing I need to do is disconnect this connection. So I'm going to, at the top here, is I'm going to say if connection is not equal to nil, then connection disconnect and connection equals nil. So when we receive a new seat event, if there was a previous connection, we're going to disconnect the connection and set this connection variable back to nil. And if the seat is set to nil, meaning we're not sitting down, we simply exit from this function, and this part of the code does not execute. The next time we sit on a seat, connection will be equal to nil, so this part will skip, and this will be equal to the new seat that we've just sitted on, and then we set the new connection for the new seat we've just sitted on. So if we play the game again, and if we sit on the seat, we can see we're getting events. If I jump off, we're no longer getting events, and if I sit again, we should hope that we don't receive 2 events of each, and we can see that we only receive 1 event, so it's working correctly. If you remember from our server script, we checked the name of the seat to make sure it was a vehicle seat, so that we only receive network ownership if it's a vehicle seat. Now I want to do the same over here so that I don't create a connection for any other seat but only the vehicle seat, or whatever unique name you decide to use. So I'm going to copy this line of code from here, and I'm going to paste it here. So we no longer create connections for any seat, only seats that have the name vehicle seat. Now let's first do the throttle float. So I'm going to need to change the angular velocity and the motor max torque for these cylindrical constraints. So once we're sure that the name is vehicle seat, I'm going to store these cylindrical constraints in a variable. So I'm going to say local cylindrical back left equals seat part dot parent dot, and this is the wheel back left dot, and we're going to get the cylindrical constraint, and we're going to do the same for the back right wheel. So cylindrical back right, wheel back right. And now I'm going to use the torque value to calculate the torque that we're going to apply on the cylindrical constraints. So to work out how much torque to apply, I'm going to say local torque equals, and we're going to use the seat's throttle float, and say seat's throttle float times, and we're going to times it by the seat's torque. So I'm going to say seat dot torque, and this torque is kind of low, so I'm going to increase it to 5,000, so we have a greater amount of torque. And I'm now going to set the cylindrical constraints torque value. So if we look at the cylindrical constraint, we can see that there is a motor max torque. So I'm going to copy this cylindrical constraint, and I'm going to say dot motor max torque, and then I'm going to say equals to this torque value. I'm going to do the same for the other cylindrical constraint, so the back right cylindrical constraint. Now this motor max torque value does not work with negative numbers, and our torque will currently go into the negative value. So to prevent this from being a negative value, what I'm going to do is say math.abs, and I'm going to wrap the throttle float in this ABS function. And what this ABS function does is it converts negative numbers into positive numbers. So now our torque will always be a positive number. The next thing I'm going to do is say if torque equals 0, then torque equals 2000. So what this is going to do is, if the player is not pressing any throttle, the torque will default to 2000, the same way we set the torque here to 2000, and this is going to act like a engine brake, which will slow the car down when you're not pressing any throttle keys. And if you wanted to, instead of hard coding the value of 2000, you could add an attribute to the seat and use the attributes value, so it's easy for you to dynamically add and remove this number to each individual car. But for this video, I'm just going to simply set the value to 2000. Now let's do the angular velocity. So I'm going to say cylindrical back left dot angular velocity equals, and to calculate the angular velocity, what I'm going to do is say math dot sine, and what this does is, if the value is less than 0, it's going to return -1. If the value is 0, it's going to return 0, and if the value is greater than 0, it's going to return 1. So sine, and I'm going to use the seat throttle value. I'm actually going to store this in a variable, so let's remove it from here, and I'm going to say local angular velocity equals. Okay, and for now I'm just going to multiply this by a large number, and I'm going to set this to this value. I'm going to do the same for the back right cylindrical constraint, and if I play the game, and jump on the seat, I should be able to move the car back and forward. And I can open the seat, and I have the ability to adjust the torque on the fly. So if I change this to 50,000, you can see that I can do wheelies. And if I reduce this to 5,000, I can go back and forth like normal. We can also see that the max speed is set to 25, but my car can go a lot faster than 25. So you can see I'm currently at a speed of 200, and it keeps going. So let's fix the max speed. I'm currently just going to delete these prints because I no longer want to see them. And now, in order to calculate the speed, we need to adjust this value here. So currently I'm rotating the wheels at 10,000, and we need to calculate the speed carefully if we want to match the max speed value. So to calculate this value, up the top here, I'm going to say local max angular velocity, and I'm going to say that equals 2, and I'm going to get the seats dot max speed and I'm going to divide that, and we must divide the max speed by the radius of the tire. So that is the distance from the center to the end. So what we can do is say, put it in brackets, and I'm going to get the back right wheel dot size, and if we look at the back right wheel, we can see that we can use either the Y or the Z axes to get the radius. So I'm going to say dot Y, and I'm going to divide it by 2, so it's from the center of the wheel. So instead of simply putting this 10,000 value, I'm going to replace 10,000 with max angular velocity. And if I play the game, and if we look at the vehicle seat, we can see that the max speed is 25. So if I sit on the car and go forward, we can see that the car only goes up to 25, well, slightly under 24. And if I get off the car and change this to 40 and go back on the car, now it should go up to 40. So now let's do the steer float. So let's first clean up this code slightly. I'm going to move this to be here and move this here. Oops. Like this. Okay. So to steer the car, what I'm going to do is inside of the body, I'm going to rotate the front attachments. So I'm going to create a local variable called attachment front left equals seat part dot parent, and if we remember correctly, we set the body as the primary part, so I'm going to say primary part, and then I'm going to get the front left attachment, and I'm also going to do the same for the front right attachment. So I'm going to say FR, FR. So now let's calculate the orientation inside of the steer float change property. So I'm going to say local orientation equals vector3 dot new, and if we look at the attachment and we look at the orientation, we can see that we rotated on the Z axis by 90 degrees. So I'm going to have the same 90 degrees here. And we're going to want to rotate the attachment along its Y axis. And if we look at the vehicle seat, if you remember, we're going to use the steer float. So I'm going to say seat part dot steer float, and I'm going to multiply this, and I'm going to use the turn speed. So if I set the turn speed to 30, so I'm going to say times seat part dot turn speed, and I'm now going to set the attachment's orientation. So I'm going to say attachment front left dot orientation equals orientation, and I'm going to copy and paste this and do the same for the front right attachment. And if I play the game, and if I jump on the seat, now if I press left, the attachment rotates to the right, and if I press right, the attachment rotates to the left. So currently the rotation is incorrect, but you can see that we can now turn the car. Another problem you'll notice is when I press the button, the rotation is almost instant. So what we could do is tween the orientation if we wanted the wheels to rotate more smoothly. So to tween the orientation, at the very top, I'm going to get the tween service. I'm then going to create a tween info. And I'm going to set this to 1 second. And I'm now going to create the tween. So over here where we set the orientation, I'm going to say tween service, create, and we're going to tween the front left attachment. Then we're going to provide the tween information. And then we're going to provide a table, and we're going to tween the orientation. And I'm going to say orientation equals the orientation value that we set here. I'm going to comment out these two here, and I'm going to copy and paste this tween, and I'm going to do this one for the front right. And as soon as we create the tween, I'm going to play the tween instantly. So I'm going to say play, and I'm going to do the same for this one over here. So we can see that we're creating a tween using a tween service, one for the front left attachment and one for the front right attachment. We're using this tween information to tell the tween how to tween, and we're setting the attachment's orientation to this orientation variable that we created here. And as soon as we create the tween, we're instantly playing the tween. And if we play the game, and if I jump on the seat, we can now see that when I turn the steering, it turns slowly and doesn't turn instantly. So we can see it's tweening slowly. Now let's fix the incorrect direction. To fix the incorrect direction, all I'm going to do is change this to be a negative. So we can say negative steering float times the turn speed. So let's delete these two lines that we commented out. And I'm going to slightly increase the speed that the wheels turn. So I'm going to reduce the 1 second down to 0.4 seconds. And if I play the game, and go on the car, see I can turn, and if I select the vehicle seat and see we have the value of 30, so if I change this to 40, let's do 90, now you can see that I can rotate my wheels by 90 degrees, which is kind of weird. And if I wanted to rotate by a smaller amount, I could set the turn speed to 10, and now we only rotate by a small amount. And if I want to go back to 30, I can set this to 30, and now we rotate by 30 degrees. Now let's move the seat to be inside of the car so that we don't sit on the hood of the car. So the first thing I'm going to do is select the vehicle seat, and I'm going to set the transparency to 1, so it's invisible. I'm also going to set can collide to false, can query to false, and can touch to false. I'm then going to move the seat, and I want to move the seat as low as possible so that the car has a low center of mass, which is going to help it from flipping over, so it won't flip over as much. And so I want it to be about there, and I also want it to be in the center, so we have a nice center of gravity. So something like this should be good. And inside of the seat, I'm going to put a proximity prompt, and I'm going to change the action text to drive and the object text to car. And it's very important that we say return requires line of sight off, because we don't have line of sight of the seat. So make sure to turn this off, or you won't be able to see the proximity prompt. You may also want to change the distance, but I'm going to just keep it at 10. Now inside of the vehicle seat, I'm going to create a new script, and I'm going to delete this line of code here. I'm then going to store the vehicle seat in a variable, so local seat part equals script parent, and I'm now going to connect a function to the triggered event for the proximity prompt. So seat part dot proximity prompt dot triggered, and I'm going to connect this function, and this function is going to return the player who triggered the proximity prompt. And when someone triggers the proximity prompt, I want to call the sit function for the part, and I'm going to pass the player's character's humanoid. So if I play the game now, and if I go next to the car, we can see the proximity prompt appears, and if I press the E key, I enter the car. Now one problem is this proximity prompt stays here even while I'm sitting down, and a second problem is if I jump to exit, I get stuck in the car. If we look at the vehicle seat, we can see that there is a property called occupant. So if we scroll down here, we can see there's an occupant, and the value is equal to nil by default. So I'm going to listen for when this occupant value changes in order to enable or disable this proximity prompt. So I can do this by connecting a function to the property change. So I'm going to say seat part get property changed signal, and I'm going to ask for the occupant property, and I'm going to connect a function to this change. And when the occupancy does change, I'm going to say if occupancy equals nil, then I'm going to set the proximity prompt enabled dot enabled equals true, else I'm going to set this to false. So when the occupancy is equal to nil, the proximity prompt is going to be enabled, and when someone is sitting inside of the seat, then the proximity prompt is going to be not enabled. And if I play the game again, and if I enter the car, we can see that the proximity prompt disappeared, but we still have the problem of me getting stuck inside of the car when I try to jump out. So what I'm going to do is inside of the vehicle seat, I'm going to create an attachment, and I'm going to position this attachment where I want the player to teleport when they exit the seat. So I'm going to move this off to the right or the left and slightly move it up. And inside of the local script, at the very top, I'm going to make a new variable called local exit attachment equals nil. And I'm now going to put some code inside of this return. So if the seat is equal to nil, which means that we've exited the seat, I'm going to say if exit attachment equals nil, then return. But if our exit attachment is not equal to nil, then I'm going to set the character's primary part C-frame to the exit attachment's world C-frame. And I'm also going to set exit attachment to nil. And finally, when we do sit down on the seat, I'm going to try to find an attachment inside of the seat. So I'm going to say exit attachment equals seat part find first child of class attachment. So what this is going to do is it's going to attempt to find an attachment inside of the seat. If it finds an attachment, it's going to set the exit attachment to be that attachment. And then when we leave the seat, if the exit attachment has been set, we're going to position the character to the exit attachment, and then we're going to set the exit attachment to nil. So if we play the game once again, and if I go to the car and press E to drive, and if I drive the car, and if I press the jump key, we can see that my character was teleported to the exit attachment. So we can do it again. I can jump and I teleport to the exit attachment. There is a slight problem with the exit attachment, and that is if I go into the vehicle seat, so vehicle seat, and if I set the max speed to 100, and let's set the torque to 10,000, and if I drive the car and flip the car, now if I try to exit the car, it's going to teleport me down here where the exit attachment is. So if I jump, it teleported me on the bottom side, and if your terrain or the world has a gap underneath, your player could fall to the -500 where your character will get destroyed. So instead of having only one attachment where the character gets teleported to, I'm going to have multiple attachments and select the attachment that is better suited to exit the car. So let's duplicate this attachment, and I'm going to set the position from -6 to +6. So we now can see that we have two attachments, one on this side and one on this side. I'm then going to go back into the local script, and instead of storing the exit attachment, I'm going to store the seat instead. And here where we find the first attachment, I'm just going to store the seat. So I'm going to say seat equals seat part, and then I'm going to delete this part here, and I'm going to change this exit attachment to the seat, and I'm going to comment out this line here, and I'm also going to change the exit attachment to seat here. So when we enter a seat, we're going to store that seat in this variable, and when we exit the seat, we're going to check to make sure if the seat was set. If the seat was set, we're going to, in this part here, we're going to loop through every attachment and select the appropriate attachment. And once we've done that, then we're going to set seat to nil. So I'm first going to loop through every child of the seat. And then I'm going to check each child to make sure it's an attachment. So I'm going to say if child.className is not equal to attachment, then I'm going to skip using the continue command. And before we start looping each child, I'm going to create a variable called attachment, which is equal to nil. And I'm also going to create another variable called height, which is equal to negative math.huge. And so what I'm going to do is, if any attachment is higher than this height, I'm going to set the child to this attachment variable. So what I'm going to do is say if child.worldPosition.y is less than height, we're going to skip, but if it's more than height, then I'm going to say attachment equals child, and I'm also going to say height equals child.worldPosition.y. So once this loop has finished looping through every child, we should have the highest attachment stored in this attachment variable. And so once we have the highest attachment, I'm going to cut and paste this down here and uncomment this. And instead of using the old exit attachment, I'm going to use the highest attachment. And so if I play the game again, and if I enter the car, and if I flip the car to the right, and if I jump, we can see that I exit from this door of the car. And if I play it again, and this time flip the car in the other direction, I should now exit from this side of the car. Another way we could write this code that may be less confusing is, instead of having a return here, I can change this to else, and then I could move this code into the else. So paste it here. So now it might make a bit more sense that if the seat part is equal to nil, we do this, and if the seat part is not equal to nil, we do this. Now let's finally go over each script. So this script here is the sit script, so I'm going to rename this to sit, and all this script does is when you trigger the proximity prompt, it's going to seat the character into the seat, and when a occupant is added to the seat, we're going to set the enable to false, and when the occupant leaves the seat, we're going to set the proximity prompt enabled to true. And the script inside of serve script service is the network owner script, so let's rename this to network owner. And what this script does is, when a player is added to the game, it attaches an event for when the character is added to the game, and then it detects when the character sits down or sits up, and if the character is sitting up, we skip. If the seat the character sits on is called vehicle seat, then we set the seat's network owner to the player, and then we print this into the output. And finally, we have the drive script, which is a local script. So I'm going to rename this to drive. And what this script does is it connects the seated event on the character's humanoid. And if the character is not sitting on a seat, meaning they're getting up from a seat, and if we have stored the seat value, we're going to loop through every child inside of the seat and find the highest attachment on the y-axis, and then we're going to teleport the character to that attachment, and we're going to set the seat variable back to nil. But when a character does sit down, and if the seat is named vehicle seat, we're going to store that seat into the seat variable, and then we're going to retrieve the vehicle's front left attachment, front right attachment, and the back left cylindrical constraint and the back right cylindrical constraint. Then we're going to calculate the maximum velocity using the max speed value of the seat part, and then we're going to create a connection with the seat part changed event. So when the seat part steer float changes, we're going to calculate the orientation of the two attachments that we want them to be, and we're going to tween them into that orientation. And when the throttle float value changes for the seat, we're going to calculate the torque, and we're going to calculate the angular velocity, and we're going to set the back left and back right cylindrical constraints, motor max torque and angular velocity. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.
Yeah.